Welcome to this exciting question, which is under static equilibrium, and it is on number 5 in derivation number 8. So it is a question where we've been given this kind of a fluid system, and we've been given this load L1, and also this one L2 and L3, and this is angle 40, this is angle 50 degrees. 40 degrees, 50 degrees. Now from this scenario, we're going to come up with a free body diagram which looks like this one. So this is the same. So the tension in this cable and the tension in this cable are equal, and also this one and this one are also equal. So from this point, what we're going to do is the free body diagram looks like this. So this one, if we want, we can just begin resolving right from this to say 40 in the x direction, it will be 40 L sine 40, in the y direction L cos 40. But if we want, again, we can do this. Since we know that this is a right angle, this one we have 50 here. This one will be 40. It is 90 minus 50. We have 40 degrees here. Similarly, this one is going to be 50 degrees. It is 90 minus 40. We are going to get 50 degrees. So from this point, we can resolve this system in x and y components, where we are just going to do this and also this, so that we have the y components and the x components. So from this, we can proceed as follows to say we know that the summation of forces in x must give us 0. So we have L1 cos 50 and also L3 cos 40. So we can begin by saying this one, it is okay, L1, okay, or L3 cos 40 degrees minus L1 cos, this is 50 degrees, cos 50 degrees. For this one, we need to get a 0. So that L3 cos 40 degrees is equal to this is L1 cos 50 degrees. And if we want, from this one, we can even divide by cos 50 degrees, also here by cos 50 degrees, so that we have L1, we are going to have L3 cos 40 degrees divided by cos 50 degrees. So we can call this as equation 1. And in a similar manner, we know that summation of forces in y, must also be equal to 0. So we have L1 sine 40 degrees, sine 50 degrees, plus L3 sine 40 degrees minus this one, minus 300 newtons, must give us a 0. So that when this crosses the equal sign, we are going to have L1 sine 50 degrees plus L3 sine 40 degrees is equal to 300 newtons. But we know that L1 is equal to this. So we can plug in this into this one. So we are going to have L3 cos 40 degrees over cos 50 degrees, then sine 50 degrees plus L3 sine 40 degrees, which must give us 300 newtons. So from this point, let me just see, erase this part, this one. We know that from fringe identities, we know that sine over cos, it is tan. So we have L3 cos 40 degrees, then tan 50 degrees, this one. So this one and this one turn then cos 40 degrees plus L3 sine 40 degrees, which must give us 300 newtons. So if we patch on a calculator, cos 40, since this is L3 and this is L3, we are going to add these the components after evaluating for cos and tan and sine. So cos 40 degrees tan 40 degrees, so this is the multiplication, plus sine 40 degrees. So that one we are going to have 1.5557 L3. This must give us 300 newtons. So if we divide it throughout, 557, also here by 1.5557, we are going to get, so this and this will go, and the L3, we are going to get 192.8 newtons as the value for L1 or for L3. And for L1, we know that L1 is equal to L3 cos 40 over cos 50. So we plug in this value, 192.8 newtons cos 40 degrees over cos 50 degrees. What we're going to get is this one times this one, we're going to get 229.8 newtons as the value for L1. Thank you so much for watching the video, and please don't forget to subscribe.